I'm Adam Greig, and this is my report for SIT718 Real World Analytics Assignment 2. Section 1, Understanding the Data. This report will focus on red wine quality score based on the physicochemical tests across 5 input variables. The sample size of this study will be 500 randomly selected results from a large data set of 1599. Starting with citric acid, it is positively skewed with a mean slightly higher than the median. There are no outliers present. However, there is a moderate skewness noticed and a positive correlation between citric acid and red wine quality. The variable X2 chloride, we can observe no linear correlation between the chlorides and the wine quality in the scatter plot. In fact, the Pearson correlation suggests that there is a non-linear relationship. We note a large number of outliers are present in the box plot, and the histogram confirms the extreme positive skewness of the dataset. Similarly, X3 variable sulfur dioxide is right skewed with no significant correlation to wine quality and a moderate number of outliers to the right of the upper fence. X4 variable pH level is normally distributed with only a few notable outliers, no linear correlation to wine quality, and the data is concentrated between 3 and 3.6 pH level. X5 variable is positively skewed to the right, displays a moderate positive correlation with red wine quality and no distinct outliers. The Y variable of interest wine quality score is normally distributed with a slight skewness of 0.1899. This slide details the key summary metrics across all the variables. The Euclidean and Manhattan calculations indicates that the X variable citric acid is generally more clustered together as compared to other X variables. Section 2, Data Transformation. The first notable issue to address is a mix of positive and negative Pearson correlation results detailed in the 5th column, followed by any skewness results outside the ideal range of negative 0.5 to positive 0.5, and finally converting all data to a standardized scale between 0 and 1. There will be a total of 3 transformation procedures undertaken: negation for X3 and X4, polynomial transformation to address the skewness in X3 and X5, followed by a min-max standardization across all variables. The negation procedure will flip the correlation from negative to positive in the case of sulfur dioxide and pH level. Polynomial transformation significantly reduces skewness in X3 and X4, and the min-max procedure was performed across all X variables. Overall, the quadratic mean model ranked best across most of the measures, with the lowest RMSE score, which was the deciding factor, given it accommodates a wide error range as well as being able to predict an absolute value. In terms of variable weights and importance, for the quadratic mean model, X4 had the highest importance at 70.4% amongst all variables. Given the input, model selection, and weights, the predicted value was 4.457, rounded to 4. This was reasonable considering that 2 input variables, pH level and alcohol, were new minimums, noting their importance in relation to quality, i.e. the taste is not too acidic and the wine body is not too watery. Key findings focus on the importance of alcohol in terms of wine quality, and that variables that have a tangible influence on the senses have a more positive impact on wine quality. The best conditions to produce a high quality rating wine would likely include citric acid within a tight range of 0.25 to 0.3, sulfur dioxide between 30 to 50, but more importantly, pH level between 3.3 and 3.5 and alcohol concentration slightly above the mean to the high end of the scale. These last 2 variables are the most tangible in terms of quality as they directly impact the senses, taste, smell, and sight. There are a number of limitations in the model, particularly as the weights were highly skewed towards one variable, which could result in over or underfitting. Not to mention that the data variables themselves were limited, and there are a number of other external factors in wine production not considered in the model or the end quality score. All material referenced in this presentation is referenced here. Thank you.